and focus on valence electrons. So in chemistry, we spend a lot of time with electrons because electrons determine the chemical properties. So valence electrons. Valence electrons, they can be transferred between elemental atoms to form ions. And the reason that one atom will give away electrons and another one will gain or accept the electrons is to increase the atomic stability. At the end of the day, every atom wants to have an electron configuration that looks like a group 18 element. So an ion carries a charge. And the reason it carries the charge is because the number of electrons has changed, but the number of protons has remained the same. So the ratio of proton to electrons has changed. The structure's identity, which is based on the number of protons, has not changed because the number of protons remains the same. So if you change the protons, you change the identity. But the structure's charge has changed. It's no longer neutral. So the structure's charge has changed because there's a change in the number of electrons. So therefore, there's a change in the number of electrons to protons. And whichever count is greater will determine the overall charge of the structure. So we have two types of ions, which we have talked about, okay, is the cation versus the anion. So when an atom forms a cation, the atom loses one or more valence electrons. And when this happens, the number of valence electrons is now less than the number of protons. And so now the protons outnumber the electrons. So the cation carries a positive charge. And because something leaves the structure, the cation is smaller than the atom because it lost part of its structure. Now, the cation has a name. The cation name is the same as the atom plus the term ion. Okay, let's go over to the anion. An anion forms when the atom gains valence electrons. And when this happens, the number of electrons is now greater than the number of protons. The number of negative charges is now greater than the number of positive charges, so the anion carries a negative charge. The anion is always going to be bigger than the atom because things were added to its structure. Now, the anion also has a name. It is a variation of the atom's name. So the anion name has a different ending. So an anion, its name will end in IDE plus the term ion. So let's look at a couple of examples here. So here we go. Example, a sodium atom. Sodium atom, its configuration is 2-8-1. When we draw its Lewis dot diagram, we have Na, it only has one valence electron, so it has one dot. And what happens is that if you go and look on the periodic table, the sodium ion, its oxidation number on the PT, it shows in its upper box a +1. So the sodium atom, it will lose an electron. So instead of being 2-8-1, it now has a configuration of 2-8. How many electrons are now in its original valence shell? There are no electrons there. No more electrons in the third energy level. And because of that, the Na does not get any dots, 0 dots. But we have to show that it's a cation, and if it's an ion, the ion is always put in brackets. Now, the type of atoms that tend to form cations, if you look at your periodic table, you'll notice that the ones who have positive oxidation numbers listed first, or only positive oxidation numbers, tend to be left of that stair step. So metal atoms tend to form cations. Their most common charges on the common charges or oxidation numbers on the periodic table are positive. Take a look, an example, fluorine. So fluorine, as an atom, its configuration is 2-7. And when you take a look at fluorine, you draw its dot diagram, it ends in 7, so it gets 7 dots. So remember, first one, second one at noon, third one at 3, fourth one at 6, fifth one at 9 o'clock. We got 2 more, so now we go and pair up at 3 and 6 o'clock. Now notice, the fluorine atom becomes the fluoride. So if you ever see it ending in "ide," that's your clue that this is an anion. And if you look at the periodic table, fluorine's only listed oxidation number is a -1. Why is it a -1? Because the fluorine, it gained an electron. So its configuration goes from 2-7 to 2-8. So now its original valence shell is still N equals 2, second energy level. Now instead of having 7 dots, the fluorine atom is now a fluoride because it has gained 1 extra. And because it gained that 1 extra, it now carries a negative charge, and we must put it in the brackets. So, to form anions, we look at the first most common charge, the oxidation numbers on the periodic table. We tend to see only anions or negative charges to the right of the stair step, so that is nonmetals. So nonmetal atoms tend to form anions. Nonmetals tend, their first charge or oxidation number in the periodic table is negative.